My project was Snap Circuits, my technology was Snap Circuits, and my launcher was Snap Circuits Level 1 and 2. There are multiple in there. My challenge was to build different circuits and understand the electricity. My SMART goal, specific, I'll use the Snap Circuits set to build circuits that control different parts and functions by looking at the launcher and following instructions. In these Do It days, I'll be able to do more than one launcher and follow their instructions and advance in knowledge to the next launcher. I'll be able to complete this goal because I have all the needed resources and the knowledge from the What You Should Know tab. I'm creating this because this is the last project and I wanted to do something new to me and learn something I have little knowledge in. Time-based, I'll reach this goal by doing a different launcher on 3 of the 4 days. Drake. About my technology. Snap Circuits is an educational toy that teaches electronics with solderless, snap-together electronic components. Each component has the schematic symbol and label printed on its plastic case that is color-coded for easy identification. You can build projects such as FM radios, digital voice recorders, AM radios, burglar alarms, doorbells, and more. Relating my launcher to the real world, Snap Circuits are a simplified version of real-world wires and electricity. Wires, Snap Circuits. What did I learn? I learned about how electricity flows and how to put together the parts. I learned that the main pieces get set on the bottom and the connector pieces go on the bottom. I learned about how many of the pieces of the Snap Circuit set work together, as well as using external power sources to power my circuits. What problems did I have? I had a few issues during this launch, but none of them were very major. The worst problem that I had was that I was gone one day, and the first Do It day was spent journaling. The only other thing that I could say was a problem is that I had to trial and error my way through things. Successes with the circuits. I had quite a few successes considering my relatively low knowledge on this topic coming into this. On the next few slides, I'll show some of my circuits that I made correctly and tell what I learned. Circuit 1. This was the first circuit I learned with. I learned how to put the Snap Circuits together and what the different parts were. It's only a simple circuit. When you press the button, it turns on the light. But I feel that it was a good start. Circuit number 2. This was the second circuit that I made. Ignore that. It launches fans, and I can turn the motor on and off with the switch in green. On this circuit, I learned that when I reverse the positive and negative, the motor spins backwards. Fan don't launch. Circuit 3. The circuit I did not make by myself, but I did learn how it works. The circuit is a 3-way switch, which can transfer power to 2 different things separately. This power source is going to here and to here, powering this. When it switches this back and forth, flipping this thingy, which powers just one of the lights separately. Why I did several launchers in one? I did several launchers in one because each launcher included one of the Snap Circuits. I felt like I could expand my knowledge further by doing more than one and seeing what the different parts do. I ended up learning more this way, and I think it's better than doing one Snap Circuit launcher per project time. My conclusion, my challenge was to build different circuits and understand the electricity. I believe I met my SMART goal because I did the number of launchers and circuits I said I was going to do, and I learned what I wanted to do about electricity. I would continue with this launcher, but this is the last launcher of the year. I like the circuits I was able to create and the freedom of choosing the circuits throughout the launchers. I came into this with almost no knowledge about electrical stuff, and I now know a lot more about it.
Logan, 1 or 2?
64.
What? That way you know that it ran.
Alright.
You pick 1?
Fuck.
Language.
I didn't say it.
That's just it's
Full I ain't really juice.
Bridge design 2016. Okay, take this.
I'll be using the Bridge Designer 2016 to create a functional bridge that holds and runs the car over the bridge. In these 4 days, I plan on having a completed bridge that beats the $200,000 challenge. I'll be able to complete this goal because I've done this once before with Jackson, and I remember some things about the Bridge Designer application, and I know which materials are cheaper but are still good. I'm doing this because I did not know what to do, and this looked fun. Before I only built the bridge, now I'm doing it as a challenge. On day 1, I will be testing out the different materials. Day 2, I will make a plan of all the pricing. Day 3, I will have a bridge design I will be happy with. Day 4, I will modify the previous bridge and hopefully beat the $200,000 challenge. That's my technology. In the Bridge Design 2016, you're able to change the type of material you want to use. There's also many more options in the picture below. And it also allows young engineers to have this learning experience. And then, yeah, there's material costs, connection costs, product costs, site costs, and yeah, a lot. Uh-oh. Oh,
Just click the next one, dude.
wait.
Yeah.
That's the one I use, and this is the one called AutoCAD. That's what major companies use. The same thing, pretty much, but better. A lot better. I learned that I'm not very good at building bridges. I figured this out by day 1, and yeah. And this challenge was way harder than I thought it would be. In the start of the process, it takes a lot of money, and you end up starting with over $90K before you can start building. So, one of my problems was figuring out a design that would work, how I'd be able to make it cheap and sturdy without it dying, pretty much. Problem 2, same problem, was finding a design and then trying to make it under 200K, in which I was not able to find, and yeah. And well, this is how my first bridge ended up, and I was way over the 200K limit, 420,000. Yeah, it ended up working, but it was very expensive, and I believe I could have made it cheaper than that. And I used hollow bars, like right there, which is probably why it's really bendy. But yeah. Day 2, this one did not end up working, probably because it was such a simple design and not a lot of support. This price was much lower though, only $293,000, still a lot, but yeah. Day 3, today I went for an easy design and I ended up only using 19 total bars, and I also used an excavation tool, which just, that's like the bridge and it just drops it all the way down. Got some money, but yeah. And I put it lower to the ground. This ended up being the cheapest one at $287,000. And then this is different designs that I went through. And then, wait. I was not able to achieve my SMART goal. I was not able to beat the challenge under $200,000. I'd probably not end up doing this launcher again because this was hard and I don't have the brain capacity to do this. Yeah. It's a fairly easy application. I like the simple things. You're able to know where everything was after just a few days of messing around with it. I'm happy that I was able to make a working bridge at somewhat of a decent price. And yeah, I learned that hollow bars are not good at building bridges. You need other ones. And yeah.
The sour berry. It's not very sour.
Salary.
Built bridges, except I used Fisher Technic, and I did the level 2 Fisher Technic mechanical side building bridges. My challenge is to make the bridges that the book wants me to, and then make a bridge of my own design in the given amount of time, 4 days. Fisher Technic is the technology I use, and Fisher Technic can be very useful in exploring many different designs, building techniques, and ways to make a model. Fisher Technic is a very useful tool because it can be used for children of all ages. Fisher Technic can help kids understand more about building and structural integrity, not to mention all the things they can build with the different Fisher Technic sets. So we have the Golden Gate Bridge, and then we have my bridge. I learned a lot about the different type of bridges, where bridges are most commonly made, and some of the biggest bridges in the world, and what type of bridge is the most effective. The only problem I had was running out of pieces for building my bridges. So, after building any of the bridges, I had to take some pictures and then take the bridges apart to build the next one. Most commonly used bridge types. The most commonly used bridge is the beam bridge. Beam bridges are very easy to build, and beam bridges are also the simplest bridge. They're most commonly used. The place with the most bridges is Hamburg. Hamburg has 2,300 to 2,500 bridges. That's more than London, Venice, and Amsterdam put together. Fisher Technic was originally made in Waldistal, Germany. It was invented by Arthur Fisher. Arthur has made 618 million euros, making 14,000 different products. The Walsh Group is categorized as the largest bridge-making company in the world. They are also considered the most profitable bridge-making company. They are rumored to have over $686 million in profit. The revenue is $1.2 billion. The biggest bridges in the world. Danyang, the Kunshan Grand Bridge, is the longest bridge in the world, measuring at 540,682 feet. And the tallest bridge in the world is the Millau Viaduct in France. I believe I met my SMART goal. I made a bunch of different bridges, and then I made one of my own design in the required amount of time. I don't think I'd want to do this launcher again, but I wouldn't mind doing more with Fisher Technic. I really liked building the bridges and making my own design. I built all the bridges well, but to have enough pieces for all the bridges, I had to take apart the ones I made. And I learned the longest and tallest bridges in the world. I really liked learning a lot about the different types of bridges.